Welcome to HumanBodyHelp.com's line of educational videos. For more videos like this and other resources for learning anatomy and physiology, please visit my website at www.humanbodyhelp.com. Hello, this is Dr. Loach from HumanBodyHelp.com, and today we'll be going through the vertebral column and individual bones of the vertebral column. I want to start by identifying each one of these bones. This right here is the atlas. This is the axis. This is a typical cervical vertebra. This is a thoracic vertebra, and this is a lumbar vertebra. I'm going to start with the atlas. You may have heard of Atlas in Greek mythology. He was the one that held the weight of the world on his shoulders. This bone right here holds the weight of the globe, the skull, on its shoulders, and that's where it gets its name from. The occipital condyles will articulate here. The occipital condyles are structures on the inferior most bone in the skull. Some other structures we can see here. We can see transverse processes of the cervical vertebra, and in those transverse processes we have transverse foramen. Back here, where a spinous process would be, it's replaced in the atlas with this big bump right here called the posterior tubercle of Atlas. We also have an anterior tubercle of Atlas right here, and that anterior tubercle is on the anterior arch of Atlas. This happens to be the posterior arch of Atlas. Now, if this were a spinous process, these would be lamina. However, we do not have a spinous process. We have this posterior tubercle on this posterior arch of Atlas. Notice in this area right here, we have a space. Normally, in all the other vertebrae, we would have a massive bone right here called the body. The body's missing in the atlas. Some people think the body ended up on the axis right here as the dens or odontoid process. This bone right here is the axis, and because of this dens or odontoid process, it forms an axis for the atlas to rotate around. You can see the atlas articulates like this. Most of cervical rotation happens at this atlantoaxial joint right here, about 70%. Other structures we can see on the axis would be the superior articular facets, which would articulate with the inferior articular facets of the vertebra above, which happens to be the atlas. Here we can see some pedicles, which aren't well defined. We'll see that they're even better defined on the next cervical vertebra we'll look at. But these would be the pedicles, leading to the lamina right here, and then to a spinous process. These pedicles with the lamina form the vertebral arch, and they encompass this space right here, which would be the vertebral foramen. The spinal cord would be here. The spinal cord would be here as well, in this vertebral foramen. We can also see transverse processes, but they're not well defined in this bone. And again, in the transverse processes, we have the transverse foramen, which would allow passage for the vertebral artery, which would be one of the arteries that supplies blood to the brain. Some of the structures we can see on this typical cervical vertebra would be the body. Okay. We can also see that the axis has a body as well. We can identify the body. We can identify these uncinate processes. Okay. They're pointy structures that will help to contain the disc. The cervical disc would sit right here on top of the body. We can see superior articular facets here, which would be on top of the superior articular processes. We can see lamina as well as pedicles in here. And remember, the pedicles and the lamina form the vertebral arch. Some people like to think of the pedicles as being like the walls of a house. The floor would be the body, and the roof would be the lamina. Okay. Projecting off the lamina, we have the spinous process, and in the cervical vertebra, oftentimes the spinous process is forked or bifurcated. Sometimes we call this a bifid spinous. We can see transverse processes again here and the transverse foramen. And again, the transverse foramen allow for passage of the vertebral artery. Over here we have a thoracic vertebra. Just like the other vertebra, we can see a body, we can see pedicles, we can see lamina. Okay. Here's another view of the lamina here. You can see the lamina lead to the spinous process, and notice how the spinous process is long and hangs down in the thoracic spine. We can see flat, smooth, superior articular facets on top of the processes. We can see the transverse processes pointing out here and here. And on those transverse processes, there'd be a smooth articular surface for the tubercle of a rib. The rib would attach here on the body at this demifacet, and then here on the transverse process, kind of like this, and that rib would continue outward. Here's another view of a pedicle while we're here, and inferior articular facet on the inferior articular process. Right here, we have a lumbar vertebra. Notice the large body of the lumbar vertebra compared to the body of the thoracic vertebra. We still have pedicles and lamina. Okay. Here's the lamina here, and they lead to spinous process. Remember, pedicles and lamina form the vertebral arch and incides the vertebral foramen. We have smooth articular surfaces on the superior articular processes known as the superior articular facets, just like the other vertebra. We do have inferior articular facets down here on the inferior processes. We can see transverse processes here, and a spinous process back here. Now let's learn to tell the difference between these vertebrae. These three are cervical vertebrae. One thing to look at for a cervical vertebra, only cervical vertebra will have the transverse foramen for the vertebral artery. Okay, we can see it here, we can see it on the axis, and we can see the transverse foramen on a typical cervical vertebra. Notice no transverse foramen on the thoracic vertebra and no transverse foramen on the lumbar vertebra. Okay. So that's what you would want to look for first to help you identify whether a vertebra is a cervical vertebra. If it does not have a transverse foramen, chances are you're dealing with a thoracic or lumbar vertebra. Now let's look at these two vertebrae to see some distinguishing features. If we look at the vertebral canal, in the thoracic spine, it's nice and round. The spinal cord would fit in there. In the lumbar spine, it's triangular shaped. And if we look at a typical cervical vertebra, it's also triangular shaped. Okay. Another distinguishing feature we can look for would be these superior articular facets. In the lumbar spine, they face inward like clapping hands, whereas in the thoracic spine and the cervical spine, they face straight back, as if they were high-fiving somebody. Another distinguishing feature of the lumbar vertebra would be these bumps right here. Okay? Those bumps are called mammillary processes. Only lumbar vertebrae have those. Those mammillary processes are located on the superior articular processes. If you found this video helpful, click like and consider subscribing to my channel. Don't forget to visit www.humanbodyhelp.com.